Hi, this video is about measuring acceleration. In physics, we want to measure things, and to measure acceleration, we have to start by talking about the change in a value. In physics, we use this term change in a lot. The change in any value can be calculated or determined by the difference between the final and initial values. We use those words a lot too. The starting value and the ending value, in other words. So to give you a few everyday examples of this, let's say you bought a Pokemon card for a pricey $50, thinking that it's a good investment, but in actuality, it starts to tank in value and ends up being only worth $2. To find the change in the value, you put your final value and you subtract the initial value. So the final value is $2. And then the initial value was $50. To find the change in, you do 2 minus 50, and so the change is a minus $48. All right, I have a cat, his name is Pancake, and when we first got him, he probably weighed like 7 or 8 pounds. At this point, he weighs 15 pounds. So what's the change in his weight? Well, the final value, as I just said, is he is now 15 pounds, and he started out at, let's say, 8 pounds. So 15 minus 8, that means he has gained 7 pounds since he has been with us. Basically half or double his body weight originally. And finally, let's talk about velocity since this is about a physics. So an object's velocity, let's say an object was moving 2 miles per hour to the west. Okay, so that would be like a negative 2 miles per hour. And then it's speeding up, it's going faster and faster to the left, to the western direction. So its final value is negative 10 for its negative 10 meters per second for its final velocity. So I would put negative 10 meters per second. And then my initial speed was negative 2 meters per second. And I'm going to put this in parentheses here since we have another negative sign here just to not get confused. So now when we try to find the change in velocity here, we would take negative 10 minus negative 2. So that would be the two negatives become a positive. So negative 10 plus 2. This object has changed its velocity by negative 8 meters per second. And that seems like a bad thing. You're losing velocity here, but no, it just means more western velocity. Negative in this case doesn't mean lower, it means the direction in physics. So that's why we try to distinguish between regular negative signs and physics negative signs. They just mean the direction. So we could sort of write a new equation that represents this change in velocity for an object. So an object's change in velocity, that's what this delta symbol means. It just means change in. So change in velocity is the final velocity minus the initial velocity of an object. And we're just writing this equation as a simplification of this idea up here, written in English. This is written in math language. Okay, so this is the change in velocity. Now, if you recall from a previous video I've done, we have an equation for acceleration that is the change in velocity over time. So we could rewrite this equation a little bit to come up with sort of a new equation using final velocity and initial velocity. Sometimes it's a little bit more convenient to write it this way. It's the same equation, but just maybe written instead of change in velocity, we'll write it with final velocity and initial velocity. So the acceleration of an object is the final velocity minus the initial velocity over time. So let's do one more example. Let's say that you have an object. Let's say it's a car, and it starts at rest and then accelerates uniformly at 2 meters per second per second. Uniformly just means it's the same amount of acceleration during the whole process. It's uniform, it's the same in every place. So if a car is accelerating at 2 meters per second each second, how fast will it be going 1 second later, 5 seconds later? What about 8.5 seconds later? Let's figure that out. Let's start by just doing a simple little time chart here. If its velocity at the very beginning was at rest, we can say the velocity was 0 when the time was 0. This car is accelerating at 2 meters per second each second. So if it's 1 second later, how much velocity has changed? How much has it gained velocity by? 2. meters per second. Another second goes by and it changes its velocity by positive 2 meters per second. Each second that goes by, it gains another 2 meters per second of velocity. And we could say, okay, this is just going to be the acceleration of 2 multiplied by the time, how much time it is. So each time we did 2 times the time. This is not complete yet. Let's come back to this in just a second. Let's tackle the 8.5 seconds now. So to find for 8.5 seconds, we need to use that equation from earlier. So the equation that I want to use is acceleration equals the final velocity minus the initial velocity over time. And I'm going to solve this for the final velocity because that's what we want to know. What is our final velocity at 8.5 seconds? So to solve this, I'm going to multiply both sides by t to get rid of this fraction. And so that undoes the division there. And we're left with acceleration times t. Usually you write the time variable last every time, so I switched the order there. That's just the standard physics way to do it. And then I'm going to add the initial velocity to both sides here. So that gets rid of this, plus the initial velocity here. And so I'm going to flip it around too, so that the final velocity is the initial velocity plus any acceleration multiplied by how much time has passed. So this equation right here is another variation of our acceleration equation, but now it's solved for the final velocity equation. So it's a helpful variation. So you could, take note of that. So when we come back over here to the time at, t seconds, it is true that if the initial velocity is 0, then you multiply acceleration times time, and that'll be your final velocity. But let's say we did have some kind of original starting velocity, we would just need to add that on at the beginning here to account for the new final velocity. So now we're ready to figure out 8.5 seconds later, what is our velocity? So I'm going to use this equation. Final velocity equals initial velocity plus acceleration times time. Okay, so my initial velocity here was 0. The acceleration is 2 meters per second squared, or meters per second, and then 8.5 seconds is my time. I'm running off the board there, sorry. So 2 times 8.5, so that'll be 17 meters per second. And because we only have one significant figure for the acceleration, it's only listed as 2. It's a pretty imprecise measurement. We need to round this to have just one significant figure. So that'll round up to 20 meters per second for our final speed. So that's all I've got for you in this video. Remember, everything you have is a gift.